Good morning, everyone, and welcome back. You know, over the past few years, I have been scrutinizing parts to an unbelievable level. Every part, every component, testing it any way that I can possibly think of before I bolt that part into an engine. So when S&S gave me a call and said, "Hey, Kev, we'd like for you to take a look at our new HPT496 camshaft for M8s," I said, "Be careful, guys, because I'm going to look at it very, very closely." And I got to admit, I was absolutely shocked at the quality of the camshaft. That being said, the topic of today's video, we're going to talk about the quality of the cam and some of the general overview of it. Many of you have heard that term frosting of camshafts, and you've seen it on tappet rollers and things, and it completely wiping a cam out, or the tappet in and of itself. People talk about frosting. You've heard them say things about hardness layers. This camshaft here came out of a 114 with 6,000 miles on it. And you can see it is already starting. This is a stock cam, by the way. You can see on this lobe here, this frosting is happening. You can see it's starting to happen right here in this area and also on the tip of this lobe as well. The other thing we're going to talk about in today's video are tappet rollers. Notice this frosting that people speak of exists on that tappet that came out of that same bike as well. So stick around. We're also going to talk about some of the other features and benefits of that camshaft and how amazing a power increase people are getting with this thing. And but we want to get down to the sciencey bit. We want to compare the quality of that S&S HPT496 to a stock cam. So stick around. So in scrutinizing the parts, camshaft specifically, one of the first things that I do, of course, is I take the camshaft, as you'll see in this video clip here, I take the camshaft and I chuck it up in my lathe, and I zero it in, and I'm looking at the bearing surfaces. And the reason I do this is I have run across some camshafts where I would notice machining errors in the base circle. And one of the big reasons I put it in that lathe is once I get this indicated in, I want to make sure that the base circles are concentric to the bearing surfaces. Again, I've seen some where a base circle would be machined off a little bit from one to the other. The other thing I'm looking at, that as a result of what I've seen, and some of you guys may have seen it as well, where you may find some impact points or strange wear here and here on the area of the cam as you come off the base circle onto the lobe. So I like to watch that dial indicator as it rolls around and look for any unintentional little divots right as the grinder makes its lobe change, its profile change to machine the lobe. Not only have I seen divots, but I've also seen some high points in these areas as it comes over the heel. It's kind of an interesting thing. So that is part of the test that you see here that I'm spinning on the lathe. And of course, you know, when this gets installed, a degree wheel put in and everything else to verify duration and that sort of stuff. But the other thing I did was also check the accuracy of the lift on it. You can do that on the lathe as well. So that gives you a good basis of the camshaft. Now, the next thing I want to show you is the hardness testing. I'm going to roll this clip here, and we're going to compare again this cam that we are starting to see, as many of you have seen on other camshafts, the frosting, so to speak, and we'll show you what a hardness test looks like. So what this is what's called a Lieb tester. Now, there are conversions from Lieb over to Rockwell. Rockwell C is what most people are used to hearing. And it's, of course, a measurement of how hard a particular surface is. And the reason I like using the Lieb method, it is an impact and rebound system of measurement instead of actually having to pierce the surface with a diamond tip, which is what you have to do when you use a Rockwell tester. And that is essentially a destructive test method, where this is non-destructive. This is a certified calibration block that is at 793 HLD, 793 lead hardness, basically. And the way that I start this with every test, I always calibrate. So I should be able to calibrate to 793 with this using 5 measurements. So let's calibrate the machine real quick. Bear with me just a second. And just so you guys know, I'm on top of a 4-inch Starrett surface plate that is mounted on 4-inch steel legs, perfectly balanced and on the floor. So this all can be trusted. And let's calibrate it. You have to take 5 measurements. All right, I read an average of 786. I know that block is certified at 793, so I'm going to calibrate up to 793. And let's do a 3-cycle test. All right, 789, 790, 794. That's with 3 measurements. Let's do one more. That's 4 measurements. We have an average HL of 790 on this block. That is very, very close. So actually this block, as far as Rockwell C hardness, is 57.9. Now that we're calibrated, I first want to start with a stock camshaft. All right. You got to make sure these things are very clean and all this stuff. Let's start with a stock cam. Now I'll go ahead and tell you, camshafts, depending on design, should be somewhere between 50, 60, maybe 62 on the Rockwell C scale. It depends on whether or not they are a flat tappet, whether a roller tappet, that sort of thing. And it has to do in the design and whether or not it's intended to be one component of many mating components or designed to be a sacrificial part, etc. I'll get into more of that on the video. So we got to make sure we're perfectly perpendicular and solid here. This, again, is a stock camshaft out of an M8. I have a 48.1 Rockwell on one lobe. Let's check this lobe. I have a 45.2 on this lobe. I have a 50.5. And on this lobe, I have a 54.6 for an average Rockwell hardness on the C scale of 49.7. And the interesting thing I want you to see on this cam, people talk about frosting. You see the frosting here and here. In other words, it's not quite as hard as it needs to be. Remember I said you want to target somewhere around 55 to 60 for a roller style camshaft, and we have an average across all 4 lobes of 49.7. So now let's take a look at the S&S 496C. Make sure we're good and flat. And let's see where we're at here. Oh, look at that. 57 Rockwell. Let's go to this one. You want to make sure you're flat so it's not absorbing anything. You want to have a solid contact with your surface beneath, as we do right here. Okay. 57.6. That's incredible consistency. Now let's check the 2 in the middle. 55.1. And 55.4 for an average Rockwell C hardness of 56.3. Right off the bat, that tells me this is a much, much higher quality camshaft than the stock one. And because of its hardness level, it's going to last considerably longer. Now there's one point that I want to make. This is a stock tappet, all right? Notice this one is frosted over pretty bad. People talk about frosting and they talk about hardness layer, but they don't really equate that to numbers. First, let's make sure this thing is really good and clean. Now let's check the hardness layer here. Wow, 27.6. Let's spin it and let's take 4 measurements here and get an average. Now we have 35.7. Let's spin it again. 31.8 and one more. 31.6 for an average Rockwell C hardness of 31.7 on this roller. Obviously, this hardness layer is is diminishing simply because this is almost an equivalency to mild steel, which would explain the frosting that you see here. The other things, if I can get a little closer, see that? All right, so essentially what would happen is as this wears on the camshaft, this is going to become the sacrificial part. And at some point, it's going to develop a flat spot and then stop rolling, and it's going to chew the camshaft like crazy. And ideally, what we would want to see, if you have two mating parts and you do not intend in your design of those parts for one of them to be sacrificial, you should have a hardness that's very similar between the two mating parts so that they would wear evenly. But obviously, the stock tappet ain't cutting the mustard. We know that this stock camshaft does not have the hardness that it really would be recommended in that 60 range. And we know that this S&S cam, not only am I excited to see that it's approaching 60 on its hardness, we also have consistency from one to the next. Needless to say, I'm not really surprised at the quality, but it's interesting, and I'm sure you'll agree, to see some numbers actually put to it and comparisons. The accuracy of lobes, the lift, the accuracy of the center line to the bearing surfaces, as well as the lead hardness on it. Quite impressive. There are several aspects of the camshaft that I really like. Number one, it is a true bolt-in, meaning that you don't have to change springs or anything. The one thing I want to point out, the HPT496, 496 is the lift when utilizing S&S forged rocker arms. Now, if you use your stock rocker arms, which you can if you so choose, then it's going to have a 485 lift. So the difference is simply because the S&S forged rockers have a slightly different rocker arm ratio. The cam will work with an engine with a compression of 11-to-1, maybe even a little higher, which is awesome for a lot of touring builds that people are doing. I see it as being 100% suitable for even doing a 124, 128, and you know, actually building a 10-8-to-1, 11-to-1 hot rod engine, not just a stock bike, but even on the stock bikes, like on a 114. There are gains in the neighborhood of 47 horsepower and around 22, 23 foot-pounds of torque. That is unbelievable gains for a camshaft, which, you know, if you guys remember in the two-valve days, which I talk like it wasn't that long ago, two-valve days, to get those kind of gains were almost impossible. And when we're talking about gains, that actually leads me to another topic. A long time ago, I did a video on the top 5 reasons I think horsepower is overrated. And some people agreed with me, some people didn't. But I think we need to take a serious look at how you actually operate your motorcycle. You know, fact is, most touring riders never see above 4,000 RPM. So one of the things you really want to take a look at is not necessarily what your peak number is on a dyno chart, but it's the gain that you achieve anytime you make a modification, you know, dollars versus power sort of thing. That's an important aspect. But also take, as you browse and maybe do some research on the cam with other people that have posted different dyno sheets using it and stuff, take a look at the change of the area under the torque curve. Look at the entire area under the torque curve and look at how that gain is there and how the area is wider. The camshaft, this camshaft pulls that off incredibly well. And just remember, it's truly about the gain and focusing the power on where you ride your bike, and not necessarily so much what the peak number is, unless of course you're racing. And this camshaft, with all the research that I've done, when you look at the specifications, relatively short duration, relatively early intake close, all the other specs involved, it really lends itself to, again, a broad torque range happening very early and making it suitable as a bolt-in for a completely stock engine, all the way up to a 124, 128, and even bigger, 131, in that 11, maybe even up to 11.2 compression ratio range. I'm seeing it's kind of a really nice, almost fit-all type camshaft, which is very, very unusual. Remember, a camshaft can make or break a build. It actually can make or break an engine as well. And so guys, take a look at it. I know you can get them off of, they're going to be available in chain drive, they're going to be available in gear drive as well. And I'm sure with cam plate kits, oil pump kits and stuff like that, so keep an eye out for those things. They already have them available. And Thanks to S&S for sponsoring this video. I cannot wait to slide this in. I think the next 128 I'm putting together over there is going to get this camshaft. So guys, thanks a ton for watching. If you haven't liked and subscribed, please do. And I'm actually going to start a playlist because this is the first video in a very, very long series with S&S called Shop Science. Shop Science with S&S Cycle. We're going to be talking about all sorts of different things. We're going to be talking about cylinders, pistons, and how to gap rings. We're going to be talking about tensioners, tappets, and push rods, and all types of stuff. The sciencey bit, not just the how-tos. Hope you guys enjoyed the video. Take care of yourselves and each other. Until next time, have a good one.